Welcome to this explainer. We're going to unpack the fascinating, totally invisible chemistry that silently powers our daily lives. Look, if you've ever felt completely overwhelmed by those massive, heavy engineering textbooks, don't worry, I've been there. Today, we're just throwing all that academic pressure right out the window. We're just going to take some time to really appreciate the incredible, unseen world around us.
To start us off, I want you to just take a deep breath and look at the device in your hand or maybe the monitor on your desk. Have you ever actually stopped to think about what's powering the screen you're looking at right now? There is this deeply intricate, entirely unseen world of chemistry happening inside it right this very second. It's working tirelessly, literally just to keep that screen glowing and your connection to the world alive. So today, we're taking a structured, super low-pressure journey through the core concepts of energy sources. We'll explore exactly how humanity harnesses power, from the crackling fires of the past all the way to the high-tech batteries of the present. And the best part? We are not getting bogged down in dense equations. No way. Let's just focus on the elegant concepts that make our modern lives possible.
Section 1. What makes a fuel? The foundations of energy. Okay, to really start our journey, we have to look at what actually makes something a fuel in the first place, right? Well, it all comes down to a fundamental concept called calorific value. You can honestly think of this just like the nutritional calories in the snacks you eat while you're, say, cramming for finals. Just like your body extracts energy from a granola bar to keep you focused, machines extract calorific value from fuels to do mechanical work. It's simply the amount of energy or heat released when a specific amount of that fuel is burned. But, as you might guess, not all fuels are created equal. A truly useful, high-quality fuel is essentially nature safely releasing stored heat and light. Ideally, a good fuel needs to be dry. It needs a low moisture content so it doesn't waste its own energy just evaporating water. It also needs to pack a lot of heat, meaning a high calorific value. And honestly, most importantly for our safety and convenience, it has to provide a fire that we can easily control. We need to be able to start and stop it at will. Section 2. The classic three: solid, liquid, and gas. Historically, humanity's quest for energy evolved from simple solid wood fires to these massively complex natural gas networks. And if we compare these three states side by side, we see a really clear evolution as we move from solid fuels like coal to liquids like crude oil and finally to gaseous fuels like natural gas. Well, the fuels generally become more expensive to source and store, but look at the benefits. They burn so much cleaner, producing far less smoke. Plus, their calorific value, that all-important energy output we just talked about, reaches its absolute peak. So we're basically trading cost for efficiency and cleanness. Section 3. Portable power, the magic of batteries. Now, carrying around chunks of coal or a heavy tank of natural gas isn't exactly practical for our modern, on-the-go lives, right? I mean, you can't exactly power a smartphone with a lump of coal. And that brings us to the magic of portable power. The lithium-ion battery is the exact same technology quietly powering your phone, your laptop, and yeah, even those electric scooters you see zipping all over campus. It's literally a masterpiece of modern engineering chemistry, neatly packaged into a tiny, lightweight rectangle. And what makes this so incredibly special is that instead of aggressively burning a physical fuel, these batteries work by just continuously shuttling lithium ions back and forth. During discharge, these ions flow through an internal, gel-like barrier, moving from a carbon layer over to a metallic oxide layer. It's not a fire at all. Actually, it's more like an invisible river of ions gently flowing back and forth, releasing perfectly balanced electrical energy to keep your devices running smoothly. Section 4. The next frontier: fuel cells and sunlight. Now, as brilliant as batteries are, they do eventually run out of charge. And this brings us to a really crucial distinction as we look toward the future of energy. While a battery is an amazing storage device, holding a finite amount of energy within its own walls until it eventually depletes, a fuel cell is entirely different. A fuel cell acts like an endless generator. It doesn't actually store energy itself. Rather, it produces a constant electrical current as long as you continuously feed it fuel from the outside. Think of a hydrogen-oxygen fuel cell, kind of like the ones used in spacecraft. The process is this seamless, continuous cycle. A fuel, like hydrogen, and an oxidant, like pure oxygen, enter the cell. Then an oxidation reaction beautifully releases electrons. Those electrons are cleanly routed right through a circuit to power our devices. And honestly, the best part? The harmless byproduct that flows out of this reaction is often just pure, clean water. It is a highly efficient, totally emission-free power source. It's brilliant. But there's another frontier entirely, and that is the solar cell.
Unlike batteries or fuel cells that rely on chemical fuels, solar panels or photovoltaic cells capture sunlight directly. They use a p-n junction. Now that sounds complicated, but it's essentially just two specially treated layers of silicon that react to light. When photons from daylight hit these layers, they excite electrons, creating what we call electron-hole pairs. It quietly generates electrical current from pure daylight. There are absolutely no moving parts, no noise, and zero emissions.
Section 5. Your energy takeaway. A peaceful conclusion.
We have covered some incredible ground today, going all the way from early solid fuels to the invisible flow of modern energy. And here is the absolute best part. There is no upcoming test on this material. You don't need to memorize a single chemical formula. Instead, my hope is that the next time you plug in your phone at a coffee shop or feel the warmth of the sun on your face as you walk across campus, you just take a deep breath and appreciate the incredible, silent chemistry making it all possible. Thank you so much for joining me for this explainer. I really hope you found this breakdown of energy sources calming and, insightful. I'm going to leave you with this final thought. As human engineering continues to so seamlessly integrate with the natural world, what unseen power will we learn to harness next? Keep learning, stay curious, and I'll catch you in the next one.